Sebastian, number 4. What's the first step we got to do? Let's factor it. Factored it. Sebastian, is this one factored?
Yes.
Is this one factored? No. When you factor, what do you get?
X squared. Oh yeah, x squared plus 0x minus 25.
And you want to fill out the x together?
5 and negative
5 and negative 5. A times c is negative 25. B value is 0. So my two numbers are 5 and negative 5. So this becomes x minus 5, x plus 5. Okay. In math, sometimes putting out the numbers 1 are super helpful. And I'm going to put a 1 here. Because it's an identity. 1 times x minus 5 is still x minus 5. We're okay? Elizabeth, what should I do next? You can what? You can cancel it out. And when you cancel that out, that's called a what? A removable whole. So I just, what am I going to write in this box here, Elizabeth? We're going to set it equal to 0. How do you solve that? And what do you get? So on the vertical line itself, where it intersects the graph, there's going to be a hole at 5. Nancy, what did I not cross off? Yeah. So, highlight in a different color. This is what you're going to graph. Okay. The reason why I put the 1 there is you are not graphing x plus 5. That would be wrong. That would be linear. That would be a different example. Now I have 1 over x plus 5. You're actually going to have a rational function. Let's graph it. Some students are asking me, which ones do I graph? Class, can you graph this one? Yes or no? You can graph that one. Class, yes or no? Can you graph this pink one? Yes. Class, are these going to be same or different? They're going to be the same. Why do we go through all of this? So we can figure out characteristics like where the removable hole is. Now, if you're not sure if yours is correct or not, you can graph what? You can graph both. Parentheses, x minus 5. Close the parentheses, division. Parentheses, x squared, xx minus 25. I want to double check that this is correct. So if you have a graphing calculator, this can actually show you or prove to you that they're actually the same. Parentheses 1 divided by x plus 5. Use lots of parentheses. It is wrong if you actually just type in 1 over x and then plus 5, because it'll be 1 over x plus 5. Let's take a look at our graph. Okay. I forgot something, and that's why. Let's go ahead and draw the graph. And as you guys notice, I had the blue and the red, so that means they're exactly the same, right? So this actually verifies that this is correct. Draw my graph. Now, there's a couple of things there's one thing that I forgot, so let's see that now. When the leftover, if you have a fraction, a rational function, as your leftover, I need to do the third step. We need to set the denominator not equal to 0. Set the denominator not equal to 0. So I'm going to set the denominator x plus 5 not equal to 0. And what we're doing here in, I don't know, another green is the vertical asymptote. If I subtract 5, now the not equals, just pretend it's an equal sign. X cannot equal negative 5. What does this one mean? This is my vertical asymptote. This graph proves that there is no hole at 5. Oh, sorry, there is a 5. So this one is negative 5. Let's put a negative 5 right here. And let's just say arbitrarily this one is 5. So I should have had a hole right here. So let's review. Make sure it's factored. If I have to cancel them, that's a removable hole. And remember, we used to draw this vertical line. Remember, this vertical line is not a vertical asymptote. It's just saying wherever it crosses the graph, that's where the donut hole is. Okay? The leftover, if you have a fraction, the denominator you set not equal to 0, this is where your vertical asymptote is, and that's verified by the graphing calculator. Eventually, we're going to graph these by hand, which means no graphing calculator. But right now, I just want you to see the characteristics.